Good morning to all. In today's class we are going to see about another microwave junction called a directional coupler. So this is the structure of a directional coupler. You can see here we have 4 ports: port 1, port 2, port 3 and port 4. So it can be symbolically represented like this: port 1, port 2, port 3 and port 4. So port 1 and 2 forms the primary waveguide. So what here it is mentioned that port 1 and port 2 it is mentioned as the main arm, or it's the primary waveguide, and port 3, port 4 it forms the secondary waveguide, or it can be also called as the auxiliary arm. So here we can pass a signal from port 1 to port 2. So here we have a hole, so the signal that is passing through this will pass through this hole. So suppose you are passing a signal from port 2 to port 1, the signal will be coming in this direction, it will flow through this port also. So the signal that is applied through port 2 will flow across port 1 and 3. So the signal that is applied through port 2 will not come out of port 4. Similarly, if we are applying a signal through port 1, it will come out of port 2 and port 4. Nothing will come out of port 3. So that's the main concept in directional coupler. So here we are going to derive the S matrix for a directional coupler. So here we have 4 ports. So if there are 4 ports, we can write a 4 cross 4 matrix. So we can write S is equal to S11, S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43 and S44. So this is the S matrix for a directional coupler. So we can write it as equation number 1. Now we know when we are applying a signal through port 1, it will come out of port 2 and port 4. Similarly, if you are sending a signal through port 2, it will come out of port 1 and port 3. So there is no connection between port 1 and 3, and there is no connection between port 2 and 4. So we can write this as S13 equal to 0. The connection between port 1 and 3, there is no connection. So S13 equal to 0. Similarly, for this port, we can write S24 is equal to 0. Now we can mark this one as equation number 2. Now, as all the ports are perfectly matched, that means no reflection come out of the same port. So S11 equal to S22 is equal to S33 is equal to S44 is equal to 0. So mark this one as equation number 3. Now symmetry property. So we know symmetry property is Sij is equal to Sji. So S11 we can leave it, S12, S13, S14, S21 is nothing but S12, S22 we can leave it, S23, S24 we can leave it, S31 is nothing but S13, then S32 is nothing but S23, S32 is equal to S23, then S33 we can leave it, S34 we can leave it, S41 S41, it's nothing but S14. Then S42 is nothing but S24. Then S43, it is nothing but S34. So we can mark this one as equation number 4. We can see here, S13 is equal to 0. We have S13 is equal to S13. So this is going to be 0. Similarly, S24 is equal to 0. Here we have S24 is equal to S42. So this is also going to be 0. Now we can apply these conditions in equation number 1. So applying equations 2, 3 and 4 in 1. So we can apply these conditions here. So S is equal to S11, S11, S22, S23, S34, they are 0. So 0, S12, S12 is S12 itself, S13, S13 is equal to S31 is equal to 0, S14, it is S14 itself, S21, S21 is equal to S12, S22, S22 is 0, S23, S23 is S23 itself, S24, S24 is equal to 0, S31, S31 is equal to S13 which is equal to 0, S32, S32 is S23, S32 is S23, S33 perfectly matched, so it is 0, S34, it is S34 itself. Then S41, S41 is nothing but S14. Then S42, S42 is nothing but S24 which is 0. Then S43, S43 is nothing but S34. S44, S44 is equal to 0. So we have got this equation number 5. Now we can use unitary property. Unitary property, it says S into S star is equal to I. So S the same as 0, S12, 0, S14, S12, 0, S23, 0, 0, S23, 0, S34, S14, 0, S34, 0 into 0, S12 star, 0, S14 star, S12 star, 0, S23 star, 0, 0, S23 star, 0, S34, S14, 0, S34, 0 is equal to identity matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So by applying unitary property we can write this. Now to find the unknowns we can find out what is R1C1, what is R2C2, what is R3C3, what is R4C4, and in addition to this we can find out what is R1C3. So from this 5 equations we can find out the unknowns. So R1C1, first row into first column. So we can write it as modulus of S12 square plus modulus of S14 square is equal to 1. Then R2C2, second row, second column. So S12 square plus modulus of S23 square is equal to 1. R3C3, third row, third column. Modulus of S23 square plus modulus of S34 square is equal to 1. R4C4, row 4, column 4. So modulus of S14 square plus modulus of S34 square is equal to 1. Now R1C1, first row and third column. So S12 into S23 star plus S14 into S34 is equal to, here also we have star, 34 star is equal to 0. So mark this one as equation number, mark this as equation number 6, 7, 8, 9, 10 and 11. So by solving these 5 equations we can find out the unknown. So now we can equate 7 and 8. So equate 7 and 8. So for 7 and 8 the right hand side is same. So the left hand side will be also same. So modulus of S12 square plus modulus of S14 square is equal to modulus of S12 square plus modulus of S23 square. So here you have S12 square, S12 square, you can cancel it. So you will have modulus of S14 square is equal to modulus of S23 square. From this you can write S14 is equal to S23. So we have got a relation. Similarly, we can equate equation 8 and 9. So equate 8 and 9. So here also right hand will be same. So left hand side will be also same. So we can write modulus of S12 square plus modulus of S23 square is equal to modulus of S23 square plus modulus of S34 square. So here we have S24 square and S24 square common. You can cancel it. So we can write modulus of S12 square is equal to modulus of S34 square. From this you can write modulus of S12 is equal to modulus of S34. So S12 is equal to S34. We have got this relation. Now we can just give a name, mark this one as equation number 12 and mark this one as equation number 13. Now apply 12 and 13 in 11. So we can come to equation 11. So here we have S12 into S23 star plus S14. From this relation we know S14 is nothing but S23 into S34 star. S34 is nothing but S12 is equal to 0. So from this we have S12 as common. So S12 into S23 star plus S23 is equal to 0. So here you can see S12. S12 it means the input from port 2 to port 1. So this cannot be 0. S12 it is not equal to 0. So S23 star plus S23 this can be equal to 0. So this term it can be a real term. Here we have a star term, so this can be a imaginary term. So this real term we can represent it as capital P. This imaginary term we can represent it as JQ. So we have a relation S12 is equal to S34. So that can be represented as P, and S23 is equal to S14 is equal to JQ. Now we have got these two relations. We can mark this one as equation number 14 and this one as equation number 15. Now apply 14 and 15 in equation 5. So S is equal to 0, S12 is nothing but P, then 0, S14 is nothing but JQ, then S12 is nothing but P, 0, S23 is nothing but JQ, 0, then 0, S23 is nothing but JQ, then 0, S34 is nothing but P, then S14 is nothing but JQ, 0, S34 is nothing but P, 0. So that is the S matrix of a directional coupler. So here we can see one more thing. So previously we can see all the ports are perfectly matched. So we can see the diagonal, it is 0. Also we can see this diagonal, everywhere you have the imaginary term JQ. So that's all about directional coupler. Just we can recap a directional coupler. So directional coupler is a 4-port network. It will have ports 1, 2, 3 and 4. The signal that is passed through port 1 will be flowing across port 2 and 4. That will not flow across port 3. Similarly, the signal that is applied through port 2 will flow across port 1 and 3, and it will not flow across port 4. So that's the main concept. So it's a 4 cross 4, we have 4 ports, so we can write a 4 cross 4 matrix. Then all the ports are perfectly matched. So S11 is equal to S22 is equal to S33 equal to 0. Then the signal passed through 1 will not come across 3. So S13 is equal to 0. Similarly, the signal that is passed through port 2 will not come across port 4. So S24 is equal to 0. Applying all these conditions, we will get this matrix. Then by applying unitary property, S is equal to S star, S into S star is equal to identity matrix. You can write this. You can form 5 equations. By solving these 5 equations, you can find out the unknown parameters here. So to find that, first we can take equation 7 and 8 and you can equate it, and we will get S14 is equal to S23. Similarly, we can take equation 8 and 9, we can equate it and we can find out S12 is equal to S34. Now we can apply these two conditions in equation number 11. So on applying that, we will get this. So here S12, it's nothing but an input from port 2 to port 1. So it cannot be 0. So it's not equal to 0. It's a real number which is represented as P. S23 plus S23 star. So there's a star. So it means it's an imaginary term. It can be represented as JQ. Now we know S12 is equal to S34. That can be represented as P. Similarly, S23 is equal to S14. That can be represented as JQ. Now substituting these conditions in equation 5, we will get this matrix. So here all the ports are perfectly matched along this diagonal, and all the ports are imaginary along this diagonal. That's all about directional couplers. Thank you.